Hey neighbors, as you can see we got quite a bit going on right here, so let's get right into it. For those of us playing along at home, a few months ago I put out a video where we could not get a computer to output video for some reason. This is the motherboard we were looking at. This is one of the graphics cards we were looking at. This is the same processor it had, and this is the same RAM that it had. And for whatever reason it works now. I suspect, as you can see, I've got a stack here of 4 power supplies. These 4 power supplies, this one down here is 400 watts, it's an old style. This is 850 watts, unknown, problem. 1,350 watts, doesn't work at all. 1,300 watts, excuse me, doesn't work at all. 1,000 watts, works good. First thing we're going to do is we're going to prep this processor for the cooling fan with some thermal paste. Thermal paste on your processor acts as a thermal conductor to draw heat away from the processor. Draws heat up into the heat sink, which is all of the metal leaves here. That's the heat sink, and then that heat radiates to the fan, and the fan blows the hot air away, which is pretty useful whenever you need a CPU to do processing while also simultaneously not melting. I believe modern thermal paste technique is a simple pea-sized portion. Just like that. Different coolers have different installation methods. Your mileage may vary. And the CPU fan header, so that when the computer comes on, the CPU fan comes on. Up here we have our monitor of choice and a keyboard, and we are going to plug our HDMI HDMI cable into our graphics card. We're going to turn on our power supply. Power supply is on. You can see the lights on the board come on, which is nice and fancy. Got all our stuff plugged in, graphics card plugged in, CPU plugged in, motherboard power plugged in, CPU fan plugged in, and so we don't have a switch right now, and so we just need to connect the 2 switch pins, which is what we're going to do to turn this on. Normally, when you press the switch on the case that is on, all it's doing is putting these 2 connectors together, and that's all we're going to do right here. Is just we're going to use this pair of scissors. We are in boot. And we have picture. We have a BIOS. Great, awesome, splendid. Now, none of that is the point of this video. We have a different problem. More so, the point of this video is this. We need to figure out how to take these 2 shells, these 2 cases, neither of which have either side panel. Right, this one, the glass broke. Because I do have the back panel for this one, but we may need that. But there should be enough material here to cobble together one case that works well enough. We'll see. Well, yeah, let's find out. Okay, I believe my strategy at this juncture is going to be utilize this big case. This is a big Fantex model, because I have the back side to it. And then we're going to tear this down into sheet metal and components and see if we can't fabricate a door for this guy. That sounds good. That sounds like a video. Alright, first problem encountered. As you can see, this is the back door. This is the back door to the PC case, and as you can see, totally warped, totally bent. We're going to have to try to beat that back into shape first. Second problem, USB port all jacked up. If you saw our audio mixer repair, you know that we know how to fix this, but the question is, should we fix it? Because I don't know if that's going to be easy or not. Because this whole piece is like this piece. This is pulled out of the other case that we just took apart. They just kind of bolt to the front. You can see the screws here. Right, so this is all its own little component, and just like this one, you have your components soldered to a board, and there's a board in this one as well. I just don't know if it's worth it, considering we have a USB hub that we can plug into this one and use it for USB as well. There's USB on the motherboard. And I think I'm gonna actually set this up so that we won't have access to the front panel anyway. So maybe that will be fine. We'll come back to that. Let's start by trying to beat this door into shape. Alright, so now that part is taken care of, now that we have the back in place, let me kind of tell you what I'm thinking about. This is part of this other case. I'm going to do what I said I was going to do a second ago. And that is utilize pieces of this second, smaller PC case to make a door to close off this PC case. And I think I'm kind of already liking the way it's kind of manifesting in reality. Oh, you can kind of see that it fits across the gap, and we can put a nice little window right here. Yeah, that right there is going to go right here as a door, and I think that's going to be really cool that we recycled that, and that makes me happy. So in that case, we're going to have to keep taking this apart by drilling out the rivets that are holding it together, because there are no more screws holding this together. It is just little rivets. And for those of us playing at home, rivets are just another kind of fastener. They're in the same category as nails and screws. They're just another way of holding two pieces of material together, usually sheet metal. A rivet is one of the ways to put two pieces of sheet metal together, and I have a little pop rivet gun, and we may break that out and see if we can do something with that. It is also worth noting that we do have the option to add a third fan. There is enough room here. As you can see, these fans slide up and down. They're bolted in right now, but there's room here and there's room here, and so there's plenty of room for a third fan. If we wanted to stick a third fan in here, we could. Something we have to think about. This fan came out of the other case. So as a matter of fact, it's just more recycling. Yeah, I don't know. We'll see. Let's think about it. For those of us playing at home, this cable right here with the blue tip came with the case, and this is the USB. This is the blue USB 3.0 port. So that's connected to these two things. And when we connect this to the motherboard, it will allow the motherboard to be able to send signals to and from the USB port to be able to use them, which would be nice. Here's the case to be recycled. As you can see, here is a rivet. As you can see, there's not any way for us to unscrew this, because it's not a screw, and it's just a circle. Because on the other end, it's just a little nubbin. And there is nothing that we can do to undo this aside from drill it out. And just like that, we have several different pieces of sheet metal. This is the drive caddy that was in there. This is all one piece, I believe, the front and back. We're going to have to try to unbin that or figure out what we're going to do with that. And then we have a top and a bottom. And of course a pile of detritus. Okie dokie, let's figure out our strategy here. We've got some different options, okay? Option number one, we build a 3-panel arrangement somehow made out of these 2 panels and this panel, which will give us a little window into the PC and allow us to look inside. But as you can see, we're going to have to trim some, and I didn't want to have to trim any, which means the door would stick out this far, which you can't see, but it's about 2 inches over, which I don't know if I like. Option number 2, the same thing, but vertically, which the middle one with the window is too short, so we'd ignore that, and we'd utilize this one, maybe like that, which is not terrible. There's your door action, right, you see it, use your imagination. And that's not bad, that's not bad. Next option, use the whole panel, 2 little windows to be able to look inside the PC, but we're going to have to trim off this piece, which I think would be easier than trimming the other one, because with this panel, as you can see here with this panel is actually the front and the side, but it's just bent over one end to create 2 different sides. And we can unbend it, and if we bend it back and forth enough times, it should break cleanly. Which if we're going to go through and cut a piece of metal, that's probably the option I'm going to go with, because it's easy and clean and not messy. You know, easy and clean. Nextly, to this whole panel options credit, there's a very nice little lip on this side. And that lip fits right over the existing case, with enough room over here to cover the whole thing. So that's a really good option. It's a fine option. It's a good option. I think for now we're going to go with this option. Maybe find some little pieces of plastic to make little windows. Bend that side off, so that's gone, and then figure out a way to hinge it, and then call that awesome. Alrighty, that worked. I think this is going to be pretty awesome. I'm going to go through on the edge here, there's a little lip. I'm going to find a way to hammer that out probably. Break off these little tabs here that we don't need. And then I think we'll have a door. I think we'll have a door then. Maybe this side? No. I love the security, or I love the alacrity with which it shuts. Because we'll be able to put the front panel on as well, I think. Yeah, that's looking pretty good. I'm happy with that. This is a handheld sheet metal bender. You just bend sheet metal with it. Let me see if I can bend this into shape. Okay, maybe not. May have to get out the hammer. this piece of metal that we're using from the PC case, because it was made to hold a motherboard. It's got these little motherboard studs in it. So I'm going to use a 7/32 hex bit to undo them. Could be reused, but oh, okay, maybe not. 7/32 is not the right size. It just kind of... I'm kind of cheating a little bit. It's not really 7/32, but it's close enough. Okay, I've got some 1-2-3 blocks here. These are machinist tools. I'm going to use it as a kind of an anvil to beat these into shape. And let's see. Just a regular old hammer. Alrighty, so while I was out there in the garage, I grabbed this piece of aluminum. This is 0.032 inches thick. And I think if we cut it in half, I think if we cut it in half, we'll have enough, we'll have a lovely little, basically make a piano hinge for attaching this to the computer. Let's... yeah, I'm liking this. Oh, there's magnets on here. Okay, that kind of helps. Kind of. Okay, and then sort of my thought process, because the structural integrity of this piece of metal was sort of dependent on that curl that was in it that I just beat out of it. And so that's why it's kind of lost some amount of its flatness. But I think if we cut this in half, we'll have two pieces that are big enough or thick enough and nice enough to... It's got these studs, right? The same studs that the other side used. And they're designed for this. I bet there's plenty of material here to make a round little hinge on here and then rivet it to this in the nice meaty part. That sounds pretty good. I was worried about how I was going to do this, but that actually helps. That actually is a good idea. So what I'm going to do is I'm going to take this piece of metal and I'm going to curl it into a circle. So it's got a nice curvy hole on one end. And then it's going to slide right over this stud. Let me bring you in closer. Okay, so these studs right here are meant for this purpose. They're meant to hang the door on, and the door pivots or rotates, hinges on these two studs. But we don't have anything to put the door on the two studs, and it's not even really far enough to be able to do that. But I think if we take this, find something that's about the same diameter as this, roll it so there's a little curly circle, like roll the metal, roll the aluminum over itself so it's round, and so it slides over the stud, and then rivet the other part to the door. Yeah, that'll work. Okay, that sounds good. That's probably what we'll do. I've made a little mark here, a little bend here to mark where I'm going to start, and I'm going to just start trying to bend this, I guess. We might have to take a couple stabs at this. That's okay. Nothing wrong with that. This is our first time. This is our first time, so nothing to worry about. We're here for learning. not perfection. We're here to learn. We can't let the perfect be the enemy of the finished. Yeah, something like that. Yeah, let's go cut this out. Let's go see if, I think we'll just cut 2 big ones. Little hinges? Okay, let's see. So here's our sort of example hinge. And the idea is it's going to go over here, and then it's going to bend over using our sheet metal bender. Yeah. I'm quite pleased with all of this that's happening. Right? You seeing it? You get it? Okay. So let's get all this in place, maybe with a clamp. This is a tool called an automatic center punch, and it's going to allow me to start a hole. I believe I've managed to hit the existing hole, which is nice. Okay, I'm going to drill a hole between my makeshift hinge and the case, and the door, rather. Okay, neighbors. We're going to call this a first draft. As you can see, it looks, from afar, looks pretty good. I found some tiny nuts and bolts. Kind of get some fitment going, get started trying to put things in order. It looks rough. I know it looks rough, but that's okay because I'm still happy with it. I'm quite happy with the progress we made, but I know I want to do it better. I know I can do it again. And as is tradition when working on a project, you end up doing it 2 or 3 times anyway. I know I can make better hinges. So I'm probably going to focus on that. Now that I know kind of what's involved. It doesn't sit right either. Sits too low. Need to find a way to adjust the hinges. But it opens. It does kind of what it's supposed to do. But there's a lot of work to do. So let's think. We'll come back. We'll see what happens next. Okay, so we have the computer on the ground, or on the table again. We have the computer on the table again. This is the front. This piece of metal all right here. This was not on there before, but it is now. It was sitting on the ground next to me. And it turns out that when we put that in place, when we install that back in place, we now have 2 edges that we can use to align our piece of metal. That's good. That's great. Second thing I wanted to share, I'm actually really proud of my hinges. I'm really proud that I had an idea, I had a vision, I knew how to execute it, I tried to execute it, and it basically worked. And that's something to be celebrated. I'm really happy with that. But they're not going to cut the mustard on this project. We need something a little more secure, and something a little beefier, something that's going to keep everything in alignment when it opens and closes. And that's not these. But really awesome to have done this. So we need new hinges. That's kind of where we're at with all this. We need new hinges. Alrighty, just a little quick blurb here. Got Windows boot disk set up on this USB. It says Maker Made. I don't know exactly where I got this, but I've always had it. In my classroom, we used to use this to put our CNC machining programs, but now it's got Windows boot disk on it, Windows 11. I've used Linux for a few months now. I prefer the ease. I prefer the ubiquitousness of Windows, I guess. So if it's not, woefully obvious at this point, I am a hoarder. I do keep many different things, including things that one usually wouldn't keep. Things like, nuts and bolts, and zip ties, and cable plugs, and bearings, and LEDs, and USB ports, and brackets, and clips, and bread ties, and thumb screws, and thumbtacks, etc. And this is some of my collection of little bits. And if we come over here by the door, you see the rest of my collection of little bits. This whole cabinet, that whole cabinet. Now, I was looking in those cabinets because I was trying to find something to make new hinges, right? We were just doing that. And I found these. These are belt clips. And I thought to myself, hey, that's almost a hinge. So I think we might try to make something with that. Let's do that. Okay, now we got quite a few decisions we need to make on modifying these belt clips. I have two of them, one for each hinge. For one, they just are too ellipsoid. They're not perfectly round. They're more egg-shaped on top. So we're gonna have to take a hammer and beat that down a little bit. But we need to be careful about what we're trying to accomplish, because it's going to be easiest for us to overdo it. Let's actually measure the diameter of the hinge while we're here. Right, these pins that make up the fixed point of the hinge. 0.2 inches. Do we have anything that is 0.2 inches? Yeah, that'll work. Okay, so this is what we're going to do. We're going to form this belt clip around this screwdriver. And I think that might work. These are 1, 2, 3 blocks. They're machinist's tools that we can use. I need like a blunt chisel or something. Pry bar, that might work. I don't have a big bench vise or anything. Oof, okay, this may not work. This may be. Whoa, okay. I don't know, there's some kind of finish on this. I don't know what this is made of. I'm going to try to use this pry bar. As a kind of blunt chisel. Okay. Might have to scratch that plan. This is tough stuff. This is not going to deform as easily as I had perhaps planned. So maybe no dice. Okay, so I did crack it. It is brittle. It's pretty brittle. However, what a challenge. Yeah, I don't see this working. I don't see this working out for us. You know what? While we're down here, we're going to make some new feet. Now, ever since I built him, he's seen better days. He's grizzled now, missing an eye, missing a finger. But he currently guards the soft materials, like the foams that we need. Let's go with something blue, how about? Why blue? I don't know, it was just on top. So I think 2 layers would be plenty. It'd actually be perfect, actually, if we make 2 little rectangles, stack them on top of each other, glue them together, and then glue them in. Easy. Some glue from the glue section. Let's not overcomplicate things with our old friend Elmer. And again, down here. Why blue and not black? Well, part of it is because it was just on top. The other part of it is that I like to be able to tell when something was replaced or repaired. And it's part of the story. And it's part of what this object is now. It's part of what this object is now. That it was repaired. That it lived and was born again as something new, or the same, or something in between. So now when we see it, and we see the blue, we'll remember that we added them. And it will make us smile. Well, it makes me smile. To remember the things I've done and be able to see the impact I've had on things. Thank you, Elmer. So, since I started this, I've had a number of different ideas about how to make the hinges. One, I could make a jig. So the way that they really make hinges is they have a block, and that block has a slit cut in it, and there's a hole drilled through it so that when you shove a piece of metal through the slot, it curves up and around the hole. I'll draw you a picture. Okay, imagine you have a block of metal, and that block of metal has a slot cut in it, and that slot interfaces with a hole, and that hole goes all the way through the material. Then you take a sheet of metal that's thin enough to pass through the slot, and as you push it with enough force to go down through the hole, it curves around the hole and loops in on itself. And that's how you end up with that hinge shape. Now, we can do this. We can build a block that has a slot cut in it with a hole drilled through it. I can do that. The problem then becomes having enough force to shove the sheet of metal through the slot, and with enough force to have it curve around the hole. Second problem is that forcing that sheet of metal through the slot is really difficult, because you're pushing on this really, really thin edge of metal, and it's liable to bend or move in the way that you don't suspect, and that could end up being a problem. So that's a whole different solution we got to come up with. Now, normally they build these in enormous hydraulic presses with lots of pounds of pressure and special dies that you would put to protect the bending from happening. And I guess that's something we could do as well, but it's just something I was hoping to avoid. Naturally, the other thing we could do is cut this part out altogether. Use this plate, or unscrew this plate, take this part out, and just put different hinges right here. That's becoming a more and more attractive option as time goes on. That's becoming a very attractive option because of this height differential. There's a height problem right here where any hinge that we build around this post is going to have to interface with this very thin piece of very thin piece of metal. Because the original door came all the way down to here, but this door does not. It only comes down to right here. And so whatever hinge we make can only interface with the door in this little tiny piece of metal. And that's going to end up being a problem, but if we make a whole separate hinge, it sort of alleviates that problem. It's a very attractive option. Yeah, I think if we realistically take a look at our options, I think we're going to take these off, ignore the post method, and put some fresh hinges on this piece of metal, because it's going to need... There's only 2 posts, and if we take a look here, we're probably going to need some more support than that. And I think right there in the middle, right there, I think we can put a 3rd hinge. And the 3 hinges, I think, altogether will make for a more better connection. So I think that's what we're going to do. So let me take off these posts. So I've got these. These are hinged hasps, and they are part of a door that you would put a lock in. And they're not necessarily the same thing as a hinge, but I think will serve the same function. I don't know. They're kind of weird. They're kind of weird. They don't really fit very well. We may need to go to the hardware store and see if we can find some others, but let me see what else I have. Alright, in the meantime, between now and hinges, let's talk about these windows here. We have lots of airflow already in this case, and we don't want just these big windows here for dust to be drawn in. That's not going to be conducive to anything. And so we have to cover these somehow, but I like the idea of being able to see inside, and so I've got this. This is some cut up 2-liter bottle, and we're going to cut this into some squares, rectangles, and we're going to paste it in from the inside so that it's like a little window, and it's going to be really neat. I think it's going to still allow us to see inside, and it's going to still be good. I don't know what I'm meaning to say. You get the idea. Let's just show it. So as we think about the glue, so I'm going to go to the hardware store tomorrow. I'm going to get some hinges. I'm also going to get some glue to glue my plastic to the metal. There's a website called thistothat.com, and you can put, we're going to attach metal to plastic, and it's going to tell us what to use to do so. So we need some JB Weld. JB Weld is what I typically use. Clamping. How are we going to clamp? I don't know that yet. Maybe some magnets? I don't know, I'll think about it. Anyway, thistothat.com. Always use it. Back at it again. Let me show you what I got. Okay, so I actually found a bunch of hinges. I bought some hinges, the same hinges. We got some JB Weld. These are called strap hinges. I don't really know exactly why they're called that, but they look like this. And I think this is what's going to help us do what we need to do. That's less good. That's kind of going to be a problem. And that's going to end up being a problem. Shoot. Maybe these are slightly smaller. Yeah, it looks like it. Okay, let's try that. Alright, I think I'm relatively happy with this arrangement. It's not perfect, right? This is close to this, but, you know, generally, and that one's bigger than these, but that's okay. But I think that we're going to have the holes we need in the right places to be able to affix this whole thing. But we can't do all this yet. Before we do that, we need to get our windows in place. And to do that, we need to turn this over. So we can glue to the backside. Okay, for those of us playing at home, JB Weld is a two-part epoxy, steel with steel in it, steel powder in it, and when it dries, it forms basically what is a soft metal. This is probably overkill for this application. This is a largely aesthetic application. This is an artistic feature. It's not going to be holding any weight or requiring any strength, but you know, right tool for the job and all that. Get equal portions of the red and black sections. Mix it together well, which I have a little scopula from some thermal paste. And so it's all one color. Now we're gonna just spread it on, I guess. We're not frosting a cake. This is an aesthetic feature. Alrighty, it's a day later. Let's see if any of our glue actually glued anything. Rats. Okay, so it looks like we have some relatively oh man, very brittle. Looks like we have some adhesion on these three, and this one is not gonna, yeah, no, okay, redo that one. So we need to go in and sort of clean up some of this where it didn't stick and do it again, because I think that this will ultimately work. It's just going to be a matter of getting it to stick well. My apologies, everybody. I did not film. I reseated that one. I got a little rag and cleaned up my excess, then put a little stack of metal on there to keep it down, and then I went ahead and stuck that corner down a little bit better. So we'll see if that makes it any better next time, or tomorrow. Okay, in the meantime, we're going to install Windows. Oh, nothing was wrong. I just wasn't waiting long. I was just impatient. Here we go. Windows. We're installing Windows on an SSD for speed. Does not say what speed on the drive itself, but let's presume it's pretty good. I don't know why I would presume that, but you know, whatever. Here we are. For those of us who are unfamiliar with computers, SSDs have no moving parts. Oh. So it looks like we might actually have a problem with the install. Maybe we need to install Windows 10 instead. Or maybe I need to go check the BIOS settings again, because I did mess around with the BIOS settings while I was being impatient. So let's do that together here in a second. Okay, so let's go back to the BIOS settings, try to put things back to normal, and then try to wait and be patient, go through with the install. I'll check back in a second. Okay. This time, for real. No, TV turned off. Sorry, trying to keep the story on camera. So let's just kind of break down what's happening right here. It's trying to run setup, it's trying to run Windows setup, and it can't find the file install.wim. Now, I checked, I was watching the files go into the USB while we were just doing that, and it was definitely transferring. But for whatever reason, it can't find it now, and I don't know why. So, we can try to download Windows again. Maybe something happened with the download. Possible. Or we could skip Windows, download. We could skip Windows, download we could skip Windows, install Ubuntu again, which would be fine. It's not a big deal. All right, back again. Just a quick search tells me that UNetbootin may not be the best tool for this job, and actually runs into problems trying to build Windows boot disks. And so that's good news, because it means we can still run Windows. I just want to run Windows. I don't know. Sue me. And so we're going to use a different tool called WoUSB. And it says that WoUSB is better for making Windows boot disks, specifically with Linux. It's working on it. Meanwhile, this is not working. So let's add a little more, I guess. I don't know. We'll see. We'll see, neighbors. Okay. This time, for real. Hey, here we go. We don't have a product key, but that's okay. Windows 11 Home, yeah, why not? Let's do it. I accept, yeah, why not? Yeah. Couldn't find any drives, huh? Well, that makes sense. What's wrong with this drive? Alright, so the SSD that I had in mind just flat out didn't do anything. Totally dead. Which is unfortunate, because it means we're going to have to use a mechanical drive. Alright, so as you can see behind me, made progress. I didn't film this part because I was frustrated. But when I was trying to use an 8 terabyte mechanical hard drive, it wasn't working. It was saying we can't do that. We can't put Windows on that. But I was able to make. So, hey, how's it going? So a hard drive has a certain amount of space on it, and you can partition that space in a bunch of different ways. And so I took that hard drive and chopped it up into smaller bits, and one of those bits being 100 gigabytes, and it's working now. Now that I've told Windows to install on that chunk, it's working. Okay, so I know it's a hot mess over here, but that's okay. We are in business. I can go ahead and remove the boot disk that we made, and now this has Windows 11, and now when we put all this into our case, it should go. It should be a computer, and it should run Windows. Now, meanwhile, we still have to wait for this to dry. Okay, it's the next day. I've already taken this one off, very securely attached, very nice. As well, and it looks good. Okay, wonderful. Hey, I don't know, I think that looks pretty cool. That's a little messy, but for the most part, I think that's pretty neat looking. Good job, everybody. Hicimos, we did it. Now for our hinges. Okay, I just don't really like this idea. I've been playing like sliding puzzle Tetris, trying to get this to sit right against the door, and I just cannot do it in a way that I like. So I think we may forego the hinges entirely and go for some light magnets just to keep it in place in the meantime while we ponder what might happen next. In the meantime, while I get some magnets, we are going to start putting the hardware into the case. Or, yeah, putting the hardware into the case. Okay, one computer. Alright, and now to verify that everything still works. Oh, heck yeah. Because like my dragon posters, they're pretty cool. There's dragons on them. Okay, very good. Now back to the door. Alright, new concern that we want to address. Do you remember a little while ago when we were talking about adding another fan to the case? There are 3 chassis fans in this computer, and they all go into this fan controller, which is this small board. As you can see, we've got 3 fans plugged in. There's a little wire that goes from the board to the motherboard that allows you to control the fans. But if you look way up there, it's going to be almost impossible to see. Way up in there, right there, there is a 2-pin connector that needs power. This fan controller has no power, which means we're not able to get power to the fans, which means when I had the computer on a second ago, the chassis fans wouldn't come on. Which is a problem. It's a problem because of our makeshift recycled case. We don't have any way of knowing the thermal efficiency, the ability to transfer heat out of the computer through that. And it might not end up being even a problem. However, we don't know. And we want to make sure that we're getting as much airflow as humanly possible. As humanly possible. And that means we need the chassis fans to come on. And so we have to figure this out. So let me tell you what I have in mind. So I came over here to the big wall of cables, where I keep all of the miscellaneous cables that make up all the things we might need. And I look down here. These are all of my computer connector cables. And I did not have a specific connector for a 2-pin power to a power supply. There are 2 kinds of power that we can get out of the regular everyday power supply, and that's SATA, S-A-T-A, and Molex, M-O-L-E-X. This is Molex, these 4 pins, and then SATA is the same, let me show you. That is your SATA power connector. Now, just like all the rest of the things from our power supply, this cable connects to the power supply inputs and allows us to send power to various accessories, such as the fan controller in question. And while I did not have a specific connector for that, I think we have the parts here to be able to cobble something together. And so what I'm going to do is this end is going to go into the power supply, and we're going to send power to this cable. Then I'm going to utilize this. This is, well, yeah, I'm going to utilize this. This is going to connect to here. Okay, and then currently that's connected to this 4-pin connector. But we don't need 4 pins, we only need 2 pins. And so we're going to modify this. We're going to cut this apart in half and connect it to a 2-pin connector, which I also just so happen to have in supply. Here's a 2-pin connector that should fit in that connector up there in the fan controller. And if we connect these 2 wires to 2 of these wires, the right 2 wires, I'll tell you which ones are which, we should be able to get power to the fan controller and everything should be awesome. Okay, let's talk about Molex connectors. Molex connectors have 4 pins. There are 2 grounds and 2 signals. One of the signals is 5 volts, one of the signals is 12 volts. We need 12 volts for our fan controller, which means we only need 12 volts and one of the grounds. So we only need 2 of these pins because that's these 2 pins. Make sense? Okay, that last clip was from last night, and now it's the next day. And as I was thinking about my plan to cobble together a new connector for the fan controller to get the chassis fans to come on, I was worried that the wire gauge of this hoarded piece, saved piece, I don't know. I was worried that the wire gauge was not going to be compatible, because you don't want to send if you're splicing wires together, you don't want to send a heavier, a thicker wire gauge into a smaller one. You don't want to take a big, thick battery cable for a car, for example, and try to run it through a 20 wire gauge wire. It will just melt. And that kind of scales up and down. But this is, and you know, it's convenient that this is written on here. It's convenient. See that 20 gauge? And I believe this is 22, so it's basically the same. It's very close. It's as close as it gets. And generally, for those of us playing at home, this fan controller is not going to draw much current, and so this is close enough. But I'm going to go get some magnets, because I think we're just going to magnetize the door on for right now, because I just don't like any of these choices. I sit here and I think about how to do the hinges, and I think about how to hinge it on, I think about how to make it work. And I just think I want the flexibility of being able to make something different later. And so, in the meantime, we'll magnetize it to the case just to keep it on. Yeah, I think that's what we're going to do, but I gotta go get some magnets. Okay, this is what I grabbed, some ceramic magnets. I did not get the neodymium magnets because they're too strong. I'm too worried about them falling and hitting the hard drive and ultimately destroying it, because it's happened. I believe that's what's happened to this SSD that we borked. Anyway, so let's try these ceramic magnets and see if we can get the door to stick. One computer. Maybe. Yeah, it's just gotta stay there for a little bit. Okay. much better than expected. I'm very happy. Very happy that worked. Okay, now, this Molex controller has four pins that map to 4 wires. And those 4 wires we don't need. We obviously only need 2. And we actually don't need 3 or 4. We need 1 and 2. According to my research, 1 and 2 is 12 volts ground. That's what we need for the board in question. Oh, can I just pull these out? Yes, I can. Now we have a 2-pin connector. And according to the research, and this should be fine. This is not going anywhere. Let's turn this around. Let's get a good look. Okay, it's worth noting okay, so there's the fan controller, right? And see that 470 microfarad capacitor right there? Right next to that, there's a label right there that it says ground, G and D on top, ground, and then 12 volts. Now, our connector is going to go in like this, which means that the red will be ground and the black will be signal, which is opposite of what it normally is, so be careful. Okay. Now, all that being said, that's that. And here's this. And let's... Okay, and now how are we going to do this? What is the plan here? So we've got 2 options, two main options that we always have. We can solder them together and use a little bit of heat shrink to make a new wire. Or we could use some spade connectors. These are for cars though, and they're really too big for this, so let's not do that. Are these any better? Eh. Well, I guess we'll just solder it together then. That's fine. For those of us playing along at home, you've seen me solder before. If you've been watching my videos, I'll put, you know what, I'm going to try to remember to put a card up here to when I fixed the audio mixer, because that was pretty good. I was pretty proud of that. Do we have any heat shrink? Unorthodox technique, but okay. If it works, it works. Okay, that's fine. Soldering iron is unplugged. Now, normally, what you would do is you would put a little tube of wire over here and kind of shrink it down, melt it down until kind of secures your connection. But I'm going to use this electrical tape. Because it's what I have. And this may end up being temporary if it doesn't work. So we're going to just, you know. Let's, see if that works. Alrighty, I've got everything plugged in. I've got the fan controller plugged in. I'm going to take off the door because its use is not required right this second. Fan controller's plugged in. Power's plugged in. Does this work? Okay. We have power. Very good. Do we have fans? This is the question. Okay. Man, I tell you what. Don't you just don't you just love it when a plan comes together just like you drew it up? Don't you love it when you mean to do something and you do it right and it works the first time? God, isn't that great? What a great feeling. That's the best feeling in the whole goddamn world. That's why I do what I do. That's why I do this stuff. That's why I make things. That's why I fix things. That's why I build stuff. Because it worked. Thumbs up for that. Good job, everybody. We did it. Well, neighbors, I believe that we have a computer that will meet our purposes for at least a little while. Made out of recycled components. Well, recycled materials. Made out of recycled components, cobbled together. And I'm very pleased with what happened. I love doing this kind of work. I love doing things. I love making things. I love building. I love doing things that I don't know if they're going to work. I love seeing if they're going to work, and I love it when they work. Yeah. Thumbs up for everybody. Good job, everybody. Now, the only thing left to do is finish installing Windows, connect this puppy to the internet, and then go from there. And this is going to allow us to do many different kinds of things for our business. Now, if you've been paying attention, you've noticed that I've uploaded some videos called Building a Billion, where I'm building a billion-dollar company because the company that I've devised using artificial intelligence techniques, algorithmic decision-making, I very much intend to raise the money to build a school, to build the school that I intend to build, right? Which is what this is all about, Mr. Warden's workshop. Building a school. That's the school. And so this is going to allow us to do more and show you more and bring you into the process for how we're going to do that. Basically, we're going to construct the tools that we need using this computer to extract $1 billion from the economy. And we'll talk more about what that is in the series, Building a Billion. In the meantime, this is great. This works. This is awesome. We're ready to go. And now, we got to get back out on the cars before it gets too hot. It's already getting 90 degrees. It's May in Texas. It's hot. It's going to be hot. It's going to get hotter. So, we got to get back out there on the car because we got to get the trooper ready for driving. Get it inspected and insured and all that kind of stuff. Make sure all the odds and ends are cleaned up. Check the brakes, all that good stuff. And then the van. And then we got to paint the van. Hopefully during the summertime we're going to paint the van because that will allow us to do mini coats and allow them to dry because it's so hot. But we got to get back out there on the cars. We got a computer. Thumbs up, everybody. This is what it's like living a curious life. It's great. It's awesome. This is what living the curious life is all about. Doing projects, seeing if it works, finding out if it works, seeing what happens, and being proud of ourselves that we're able to do stuff. So live a curious life, everybody. I'll see you next time. Stay tuned for what happens next.